We use a base 10 numbering system to write, compare, and compute with numbers. In this video, we will explore how place value allows you to compare and order decimals. Let's start with an example. At the fruit stand, someone purchased 5.25 pounds of apples and 5.35 pounds of oranges. Which fruit did this person purchase more of? Use place value to decide. The arrangement of the digits in a number determines their place value. The digits are arranged this way. The number in the ones place goes here. The number in the tens place goes here. The number in the tenths place goes here. And the number in the hundredths place goes here. We are told that there are 5.25 pounds of apples. As you can see, the 5 is in the ones place, the 2 is in the tenths place, and the 5 is in the hundredths place. We are also told that there are 5.35 pounds of oranges. So we place the digits here. The 5 is in the ones place, the 3 is in the tenths place, and the 5 is in the hundredths place. To determine which number is greater, compare the place value of the digits. Start with the ones place. You'll see that there are 5s in the ones place. Since these are equal, we can't yet determine which number is greater. Next, we compare the digits in the tenths place. Here we see that the 3 in the tenths place is greater than the 2 in the tenths place because 3/10 is greater than 2/10. Because of this, we can conclude that 5.35 pounds is greater than 5.25 pounds. So there are more oranges than apples in terms of weight. Let's look at another example. A paramecium is a small organism that is often found in pond water. The size of paramecia range from 0.002 to 0.013 inches. How much smaller is a paramecium that is 0.002 inches than one that is 0.025 inches? Use place value to solve. In this example, we are comparing numbers to the thousandths place. Using the digit placeholder from before, you can see that we have added the 10,000ths place here. Inputting the data for the smaller paramecium, we get this. For 0.002, there is a 0 in the tenths place, another 0 in the hundredths place, and the 2 is in the thousandths place. Now we have to show the data for the larger paramecium. For 0.025, the 0 is in the tenths place, the 2 is in the hundredths place, and the 5 is in the thousandths place. We know that this paramecium is larger because 2 hundredths is larger than 0. We also know that the 2 hundredths here is 10 times larger than the 2 thousandths here by virtue of their place value. Since the digits are identical, then there is just a 10-fold increase from here to here. But we also have this 5 thousandths value here, which is also larger than the 2 thousandths value here. By how much? Well, we know that 5 is 2.5 times larger than 2, simply because 2 times 2.5 is 5. We combine the two factors. This number is 10 times larger than this number, and this number is 2.5 times larger than this number, and we get 12.5. That means that the paramecium that's this size is 12.5 times larger than the paramecium that's this size. Another simpler way of getting this result is to use a calculator to divide this number by this number. However, it's important to be able to analyze numbers according to their place value. Let's look at a final example. How much larger is 0.0045 than 0.00064? We place both numbers in the digit placeholder. You can see that the smaller number here has digits to the 100,000ths place. Comparing the place value of the 4 here and the 6 here has this place value 10 times larger. But notice that since the 4 is smaller than the digit 6, this decimal is less than 10 times larger. To find the exact value, divide the larger value by the smaller as shown here. We can rewrite this expression as a whole number ratio as shown here. Using a calculator, we find that the larger decimal is 7.03125 times larger than the smaller decimal.